To solve question number 7, what we're going to do is, first of all, state the restrictions. So x cannot be equal to positive 1. We're dividing by the x minus 1, so that gives us this restriction. So once we've set the restriction, we can get rid of that divisor by multiplying by x minus 1. So I'm just going to move this over here and multiply by x minus 1. That will get rid of that divide, but we have to make sure we multiply every term by that x minus 1. So we get x squared minus x plus 1 times x minus 1 gives us x minus 1. The negative 2 times x minus 1 gives us negative 2x squared plus, watch your signs, 2x. Multiplying the 2 with x minus 1, we get 2x minus 2. And then multiplying the fraction, the fraction, we cancel out the x minus 1 times and divide, and we're left with just plus 5. So combining like terms on the left-hand side, I'm going to add 2x squared to both sides. I see I have a 0 pair here, so I'm just going to cancel those out. I have 4x on this side, so I end up with negative 4x. And then subtracting 5 from both sides, I get minus 6. And that's going to be equal to, oops, sorry, it's not going to be minus 6, it's going to be minus 4. Okay, so I'm going to end up with plus 3. I'm going to subtract 3 from both sides. That leaves me with minus 4 equals 0. So in this case here, we're going to see if this is factorable. So 3x squared, negative 4. I get negative 12x squared when I multiply along that diagonal. So the two numbers that multiply to negative 12x squared and add to negative 4 is going to be negative 6x and positive 2x. So I can now factor the common factors. There's a 3x here, plus 2, and then along here there's x and a minus 2 factor there. So writing this in factored form, I get 3x plus 2, x minus 2 equals 0. Now I chose to factor this, but we could have used quadratic formula here. But in the end, we get our solution of x equals negative 2 over 3 and x equals 2. Now, whenever we have these equations, we can always check by graphing. It's not a bad idea to do more and more graphing to check to see what we're doing. So in the next video, I'll show you a graphing solution of this.